Now here we solve a complete example from end to end with the help of log tables and anti-log tables. So here we are asked to evaluate the value of the expression as shown here on the screen. As you can see, it's a complicated expression, so we use the log tables to evaluate it. We start by saying that let us call this particular expression as x. So let x be equal to 23.19 into 5.7719 the whole square divided by root of 85.04. Now what do? Is we take the log of both sides to the base 10. So therefore we have log x to the base 10 equal to log of the whole expression, that is 23.19 into 5.7719 the whole square divided by root of 85.04. Now here if you look at the expression, it is some division, isn't it? So therefore we have log of some quantity upon another quantity. So therefore clearly we take the log of the numerator and from that we subtract the log of the denominator using the properties of logarithms. Okay, now in the first case, since now we have a product, that also we can break and we can say that log of 23.19 to the base 10 plus log of 5.7719 the whole square to the base 10 minus log of, now the square root quantity we can write as 85.04 raised to 1 by 2, isn't it? That is the meaning of square root. And using the exponent property of logarithm, whatever are the exponents here in the expressions, that we can bring down. Okay, so therefore the 2 and 1 by 2 can be brought down. So I'll write it on the new screen. Okay, so therefore we have log x, this is 2, and we have 1 upon 2, right? So therefore that further equals log of 23.19 plus 2 into log of 5.7719 all to the base 10 minus 1 by 2 log of 85.04 to the base 10. Okay, now we go on to write down the log quantities. You are already aware how to find the log of any number. Okay, so you refer to the log tables. Log of 23.19 will turn out to be 1.3653 plus 2 into log of 5.7719. Now here we have to just understand one point. While taking the logarithms, as we have to momentarily skip the decimal point, so you will get 5 digits, that is 57719. So you may wonder which 4 digits we have to consider. Is it 5771 only? So the answer is of course no, because since there is 9 sitting ahead, so we have to round off the 1 to 2. Okay, so while you refer to the log tables, you have to look the entry under 5772 and not 5771. Okay, so that's the only important point to be kept in mind. So once you see the log of that, that will turn out to be 0.7614 minus 1 by 2 into log of 85.04 will be 1.9296. This you can verify. You can pause the video and verify all these values. Then we go ahead. We have 1.3653 multiplying by 2, we have 1.5228 minus, now here dividing by 2 we get 0.9648. right? Now let us club the positive numbers, so we will get 2.8881 minus the last number, that is 9648, which in turn gives us 1.9233. Now this is a log of the required number to the base 10. So clearly the required number is the anti-log. Now since we have done the calculations in the log domain, now we translate it back to the original number system. So now we have to find the anti-log of 1.9233. If you remember, while checking the anti-log, we refer only to the mantissa part first and get the 4 digits, which turn out to be 8381. And since the characteristic is 1, we have to put the decimal after 3, and hence the answer is 83.81. That is the final answer.